Hello everyone, hope you're doing well with Lab2. We're going to show you how to set this up in MATLAB and Simulink. So the first thing you'll want to do is get into Simulink itself. You can do this by typing in the terminal or pressing the Simulink button at the top. Once you're in Simulink, you'll create a blank model. That'll take a few seconds. Now that you are in Simulink, we're going to create a few things. We're going to create an analog input, and that's going to be the Simulink desktop real-time, not the other toolboxes. And then once we've created the analog input, we're going to go into those settings by double-clicking it. Now, your board might be auto-selected like ours is, but if it is not, you'll want to go to Install New Board, and it'll be in the National Instruments 2. You can see the number listed in the documentation, but for your benefit, we have it up already. You can see 6321. Our sample time is going to be 0.01. Everything else should stay as is with 10, 1, negative 10 to 10 volts, and double. Now we're going to do the same thing with an analog output, again ensuring that we're using the right one. Again, you'll need to select your board and your sample time. Now you'll need to connect the two together. Now that you've configured your analog input and output, you'll need to make a scope. This scope should be in your Simulink/Sync section. You'll connect that to your input, and then press Ctrl-E to configure. In here, you want to go to code generation and make sure that your target file is sldrt.tlc. From there, your language should be C, and the rest should be as specified here. In your solver, you'll also want to make sure that your fixed step and your solver are as shown here. Now, you'll go into your scope and run a simulation. The first simulation we're going to run is of 2 Hertz. You can see that we're creating a pretty decent sine wave. And this is what happens when your sample time is roughly good for what you're doing. You can see a pretty even wave. Now we're going to go to your next frequency to test, 20 Hertz. This 20 Hertz is not quite as synchronized with your sample time. And so you can see it's sampling at odd times and is making this strange looking wave. That's exactly what you should expect to see. But when we go up to 200 Hertz, we'll see a more standard wave again. Make sure you adjust it to be almost exactly what you need it to be. Otherwise, you'll get the same sample time issues we had at 20 Hertz. So you can see a little ticks here and there, but it's relatively a good sine wave. Whenever you're running these, make sure that you're taking pictures for your oscilloscope and pictures here on the scope. You'll continue to do this for your other frequencies. Thanks for watching. This has been made by Tau Beta Pi.